guys, this is an intro to the chain rule, and just FYI with this particular video, so I'm actually trying to make it into two kind of pieces, and I'll tell you when I've explained the basics, and if you feel like you've got it, then you can kind of stop watching, but if you're looking for a much more robust explanation, then you can keep watching. So I'm trying to structure the video like that. So the best way to do this particular video is to pause and try the examples when you are prompted. Also, there are free guided notes available at divideandconquermath.com, and I highly recommend them for this particular video if you're struggling with the chain rule. The way that I set up the examples is really, really great with those particular notes. So what is the chain rule? The chain rule is for when you have a composition of functions and you're trying to take a derivative. So for instance, this is a function that you would not use the chain rule on because we know the derivative of it. The derivative of sine of x is cosine of x. But what do you do when you have something like sine of 7x? So math is extremely literal. And so the rule that we have around the derivative of the sine function is literally just for that. It is not about sine of 7x. So then we don't know actually what the derivative of this would be. And what the chain rule does is it actually views this particular function in a specific way. So it views it as a composition of functions where this sine, this is the outer function. And so we think of this as the outer function sine of x. And then the inner function is this 7x. So then this would actually be the composition of sine of x with 7x. Okay, so that's kind of the idea behind this. And the chain rule, I'll actually show you what it is. So you have this composition of functions, f of g of x. If you're trying to take the derivative of this is going to be f prime of g of x times g prime of x. So the way that I think about this is you take the derivative of the outside function and you leave the inner function intact. So you just leave that kind of still composed. And then you multiply that by the derivative of the inside function. That's always the way that I've kind of thought about this. And I'm going to show you kind of how to break it down. Okay, so I'm going to show you two examples now of the chain rule. And this is kind of like a really just quick explanation here. So looking at this function here, so first of all, this is screaming for the chain rule because you are not going to multiply this together 12 times, right? So to actually have to do that 12 times would just be crazy. So you have to use a chain rule here. So in this case, the outer function, so the outer function, I guess I'll use that pink color. So my outer function is really this thing to the 12th. So we think of this just, you'd really think of this part in the middle as your inner function. So you just take this, you'd use the power rule, right? And then the inner function is what's in the parentheses. So that's this x squared minus 8. So I'll just show you how the chain rule works. And if you're feeling like this is very complicated, don't worry, I'm going to break it down much farther. This is just kind of a really quick showing you a few examples of how it works. So taking the derivative of this outer function, x to the 12th. So you're going to bring down, I'll do this in the pink, you bring down the 12, and then you subtract 1 from the exponent, but you leave that inside function intact, and then you multiply this by the derivative of the inside function, which would just be 2x. The derivative of x squared minus 8 is 2x. So that would be your entire first derivative. And so then this is going to be just 24x times x squared minus 11. And because of the order of operations, you can't go any farther with this. Okay, so I want to just show you one more because you can have more functions kind of composed. And again, if you're kind of struggling with this, don't worry, we're going to break this all down. But in this particular example, so here's my outermost function. And then in this case, I actually have a middle function. And then this one would be my inside function. So those are actually the three, and that's usually the way that I like to identify my derivatives. So if I'm taking the derivative, so I always like to start with the outside and work my way in. I think some people start from the inside and work their way out, and you can do this more than one way. But if I just think about taking the derivative of the outer function, so this really, I want to forget about all of this for a second. I'm just thinking of what is the derivative of just e to the x in general. So that would just be e, right? And then I leave all the other stuff, this sine and this 5x, I leave those intact. And now I'm going to work my way towards the next derivative. So the next derivative here would be sine. So what's the derivative of sine? It's cosine. So I take the derivative of that, and then I leave the inside intact. And now for that final function, so the derivative of 5x, that would just be 5. So here would be all the pieces of this derivative. And so then this is going to be 5e to the sine 5x cosine of 5x. So there's your derivative. So if you feel like you've got it and you can run with it, like this would be a fine point to bail on this video. But if you're looking at this and you're saying, okay, I really don't understand what just happened, then continue to watch. So the key to this is to be able to identify what is being composed, because there's like a very specific way that you have to look at this. And so this is really important that you're able to kind of leverage the certain set of derivatives so that you can pick apart what's being composed. So what I want to do is I want to just very quickly review all the derivatives. Now, if you are still learning these, this would actually be a really great way to quiz yourself. So you could pause here, try to see if you can recite all the derivatives, and I'll show you the answer in a second. So here's the first set of derivatives. So we have to remember all of these for when we're working with the chain rule, and then I'll show you some other derivatives we're going to work with. So once again, you can pause here, quiz yourself. So here's the other list. So all the derivatives that I have, it's this list and this list. So these are kind of what we're working with, and so we want to view functions as a composition of kind of this list that we see here. So if you need to pause or rewind or whatever, feel free to. Okay, so to help you understand the chain rule, we're going to look at a certain set of exercises that have nothing to do with taking derivatives, but instead just identifying if we need the chain rule. So what I have for these following examples, which I have a lot, so I think it takes a little while for people's brains to kind of click with this, and then once you get it, usually you're good to go. So the question here is the chain rule needed, and how many and which functions are being composed? So those are kind of the two things that we're going to look at. So we're going to do this for all of these functions. So like I said, I'm going to be thorough because I want you to understand this. So let me walk you through the first two. And if you're not sure, or if you feel ready, you can just pause here and try. But so looking at this particular function, so just is the chain rule needed? So do we need the chain rule? So yes, we definitely need the chain rule here. And so then what are the two functions being composed? So we really want to identify. And so that's where you might find that you have to stare at your list of derivatives. So we have the outer function is this sine of x. And then this inner function we could think of with really using either the power rule or the constant multiple rule, kind of a combination of the two. So looking at this, so my functions are, there are really two functions. This is the outer function. Maybe I'll use a different set of colors. This is my outer function. So my outer is this sine of x. And then my inner, this is my inner. So my inner would be 3 of x. Now, for our purposes, I really think all you have to do is just kind of, I usually like just using color coding just to kind of identify these, and then identify outer, mid, inner, whatever. So these would be the two functions that you're thinking about when you take the chain rule. Okay, so I'll do one more with you. So here's another one, and we actually just did an example like this, or very, very similar. So in this case, so this would be my outermost function, and then this one would be my mid function, and then this would be my innermost function. So yes, we need the chain rule. So we need the chain rule, so yes. And then there are 3 functions being composed here, and I've just kind of marked them like this. So if you're playing along on the guided notes that I have, you might want to use like a color coding system, pens, highlighters, something so you can kind of help yourself break apart and visualize all of those. Okay, so here was the rest of the list. So I'd highly, highly recommend here that you pause and actually try these on your own if you're trying to understand this, and then hit play when you're ready. Okay, so for this one, the chain rule is needed. So the chain rule, so yes, we need the chain rule. So the functions being composed, this one here, this thing to the 7th, that's my outer function. And then this thing here, this would be my inner function, okay? All right, moving on to D. So do I need the chain rule? So this is where people start to get kind of confused. So you actually don't need the chain rule. So we need no chain rule here. Maybe I'll just start calling that CR. We'll just call it CR now. So you could just use the product rule here. So you just want to kind of break that apart in your head. There's no composition. These two things are just being multiplied together. So you can use a rule that we already have. Okay, moving on to this one. Definitely need the chain rule. So yes to the chain rule. Now, this is actually a little bit tricky. This squared is a little misleading. So remember that just in general, so I'll just maybe write this on the side. Sine squared of x, this is the same thing as sine x squared. So you might find that it's very helpful to write it out like this when you're trying to use the chain rule, because if I rewrite this function then, this is really going to be sine of cosine of 5x, and then all of that is being squared. And that's important because you have to recognize kind of the order. So here's your outermost function, this thing being squared, and then you have this mid function, and then you have this next mid function, and then finally you have this last one, this is your inner function. So there's actually 4 functions being composed using our rules as a guide. Okay, so this one is the chain rule. And this one's actually a little bit complicated because you actually have to use the product rule, and then you have to use the chain rule within the product rule. So you have to use, so you have 2 different chain rules here. And to make this easier to explain, I just moved that, so sorry about that. So we have the product rule that we have to use here, and so here's one function, here's the second function. So that's for the product rule. And then within this function, this is my outer function, and this is my inner function. And then here's my outer function, this thing to the negative second, and then here's my inner function, okay? So that's kind of the breakdown there. So that can be a little tricky to work with. And then for this last one, so this one actually is just the product rule again, so no chain rule needed here. So we're not gonna worry about that. You just multiply, you've got cosine of x times e to the x, and then this is just a constant, so that's no big deal. Okay, so now we will take the derivative of any function that needed the chain rule. So in this whole list that I gave you, I just crossed out the 2 that did not need the chain rule. So I want to make sure that I am very thorough in this video, so we're going to do all chain rules here. So once again, I will do kind of the first 2 with you, and then I will, suggest that you maybe keep going by yourself. So for this one, so we already talked about this, right? So this was the outer function, and this was the inner function. And so just so that it's nice and clear, I'm going to kind of color code my derivative. So first I'm going to take the derivative of the outer function. So the derivative of sine is cosine. And then remember, you leave the inside intact, so you don't touch the inside. But then you multiply that by the derivative of the inner function. And the derivative of 3x is just 3. So my derivative is going to be 3 cosine 3x, done. Now, for this one, we said this was my outer, this was my mid, and this was my inner. So I always like to go from the outside and work my way in. So I'm going to color code again. So the derivative of e is just e, and then I leave the rest of this stuff intact. And you can have parentheses around this or not, it doesn't really matter. Okay, so next I'm going to move on to the derivative of the next function, which is sine. The derivative of sine is cosine, so this will be cosine. Leave the inside intact, so I'll just write 4x here. And then finally, I multiply that by the derivative of the innermost function, which is 4. So now I can write this out as 4e to the sine of 4x cosine of 4x. Okay. And so now, what I would recommend actually is, so if you want to play along, maybe pause here, try the rest of these, and then hit play when you're ready. So moving on to this one, so the outermost function we said was this thing to the 7th, and the innermost function is this piece here. So if I'm taking the derivative, so I take the derivative of the thing to the 7th, so that's going to be 7, and then I subtract 1 from the exponent. I leave the inside function intact, and then I just multiply that by the derivative of the inside, which would be 4x cubed. And then I can simplify this, so this will be 28x to the 3rd, and then this is going to be x to the fourth minus 5 to the sixth. Okay, so moving on to this one. So this was the tricky one, right, where we said that you might want to rewrite it as sine of cosine of 5x and then all of that to the second. So identifying our functions. Here's my outermost function, and then there's that one. That's the next one in. That's the next one in, and I'll use blue. There's the last one. Okay, so now let's go ahead and start taking derivatives. So first I have to start with the outermost, which would be this one right here. So I bring the 2 down, and I'm going to subtract 1 from the exponent. So I'm just going to leave this as nothing because 2 minus 1, there's no need to put an exponent here. And I'm going to leave all the inside stuff intact. And I totally missed where that square bracket should go. Okay, there's the first one. So now I'm going to multiply that by the derivative of the next one in, which we said was sine. So it's going to be the derivative of sine is cosine. Leave the rest of this good stuff intact. Okay, now we move on to the next one. The derivative of cosine is negative sine. So there's that. Leave the rest intact. So times this. And now finally, what's the derivative of 5x? That would just be 5. So now we've got this whole big old mess, and there's my derivative. So if I want to write this out as a nice derivative, this will be 10. There's really no nice way to write this, by the way. This is just kind of a big old mess. Cosine. Sometimes this happens when you're practicing with these. Let's see, times, let's see, oh, I should put the negative in front here, I guess. Sine of 5x. So there's the whole thing. I know it's a little cramped, sorry, but I'm running out of room. So hopefully that is clear. Okay, and now for this last one, so we talked about how there's actually 2 pieces here. So what I'm going to do here is I'm just going to remind myself. So this stands for my f of x, and this stands for my g of x. So just reminding myself what the structure of the derivative using the product rule is. So if I have f of x times g of x, so we just reviewed this. So this is f prime of x times g of x plus f of x times g prime of x. So that's just like a little guideline for me as I go through this. Okay, so I need to start taking this derivative. Now, I'm actually going to flip the order a little bit. So since these are being multiplied together, it doesn't matter which one comes first. I'm actually just going to write the g of x down first when I take the derivative, just so that I don't forget about it, because I am a forgetful human being. So I'm going to write this part down first. Okay, so I've got that part for sure. And now I can work on taking the derivative of this f prime of x, which I know I have to use the chain rule here, right? So now, looking at this, this is the outer part, this is the inner part. So if I take the derivative of the outer part, that's bring the 5 down and subtract 1 from the exponent and leave the rest of the inside part intact. And then I'm going to multiply that by the derivative of the inside. And the derivative of the inside is 2x. Okay, so there is f prime of x, g of x. There it is, all right there. Okay, let me close that. Okay, so moving on, now I need to use the second part of this derivative. So sometimes when you do these, it's just like a lot to keep track of. And don't be afraid to write out the derivative rules, just if you kind of need that guide as you're trying to keep this all straight. It's normal to kind of struggle with keeping it all straight. Okay, so I need to leave f of x intact, but now I need to multiply this by g prime of x. So now I have to take the derivative of this guy. So let's see, I'll use a different set of color codes this time. So the negative second, that thing to the negative second, that's the outer function. And then the 3x plus 1 is the inner function. So now, if I multiply this together, this is going to be times negative 2, and then leave the inside intact, and then I subtract 1 from the exponent, so this will be negative 3. And then I multiply that times the derivative of the inside function, so the derivative of 3x plus 1 is 3. Whew. Okay, and now we're good. So we took the derivative. So now I just try to write this out as nicely as I can, which is really not going to look that nice, to be honest with you. So let's see, I could write this out as 10x, x to the second, plus 7, all of that to the fourth. And then I could rewrite this as 3x plus 1 squared. And then here, this will be minus 6 x squared plus 7 to the 5th over 3x plus 1 to the 3rd. And that's all you can do with that one. Okay, so that is it for your intro to the chain rule. So if you have any other questions, feel free to drop me a comment, or if you thought this video was helpful, it'd be really great if you gave me a like or even a subscribe. Hitting the subscribe button really helps me out. I have other example videos too if you're looking for even more practice, so be sure to check those out. Thanks for watching if you made it to the end of the video, and I'll catch you guys next time.